Okay, so for example 2, we're going to think back a little bit to our Suvat equations. We used these when we were dealing with stuff that was moving in one dimension in year 12, and we also used it in the projectiles unit. Now this, they don't all apply in vectors, right? The only two that we're actually going to use in vectors are going to be the first two here, v equals u plus at, and s equals ut plus half at squared. You can do everything you want using vectors, and those amounts as well. So we're just going to stick to those two. There's one exception, which is in vector. We've already seen I was using r rather than s for displacement. So whenever s is a displacement, is a vector quantity, so it will be r equals. So this equation just becomes r equals ut plus half at squared. Other than that, it's going to work exactly the same. So let's have a little look what we've got in this example too. So it tells us a particle has velocity at time t0, so that must be our starting velocity. So let's start by writing that down. So u equals, and I'm going to use throughout this again my column notation. So that's the initial velocity. The acceleration is given to us here, 2, 3. It asks for the speed, right? That's important. Right? It's not asking for the velocity, it's asking for the speed. So we'll come back to that at the end. And this is for when t equals 3, right? So to get the speed, we first have to get the velocity, right? And then after we've got the velocity, we will be able to turn that into speed. So it's v that we're looking for. So of our vector equation, of our motion equation, our Suvat equation, you can see this is going to be v equals u plus at. So when I substitute my values in, I get minus 3, 1 plus 2, 3 times 3. And all I have to do is use the top line of that to get the top line of v. So minus 3 plus 2 times 3 is positive 3, and 1 plus 3 times 3 is 10. Okay, so that is the velocity at that point. Because it's not asking for velocity, it's asking for speed. Speed is the magnitude of velocity, right? So speed doesn't care about direction. If we was to draw a little diagram to demonstrate that, we can see that this is going 3 across and 10 up. But actually the speed is the straight line distance. That's why it's the magnitude. The speed doesn't care for direction, it's just how quickly am I going in that straight line direction from start to end. So to get the magnitude, we're going to use Pythagoras. 3 squared plus 10 squared, which is square root of 109, which we can work out if we want to 2 or 3 significant figures. So this is 10.4 meters per second, because it's the speed, to 3 significant figures.